Hello everyone. My name is Vishnu Sundararajan. I'm a master's student in the Telecommunication Networks program at Northeastern University, Boston, USA. As part of my course requirement for the software-defined networking course, I'm doing a project on a, I'm doing a study on different SDN controllers in a wireless environment using Mininet-WiFi. And so this is the outline of my project. Uh, so. Um So while researching a potential project topic for my final semester project, um, I noticed that the performance of controllers have been extensively studied in uh, various SDN simulations using the Mininet software. They created various topologies and such. But since wireless networks is the future, I believe I I feel that it's imperative that we start studying the performance of the SDN controllers in a wireless environment as well, because I feel that SDN should be incorporated into wireless networks as well in future. So I propose to use the Mininet Wi-Fi software for creating and emulating simple wireless topologies to be studied in an SDNS environment. So in this project, I will be creating various wireless network topologies of different complexities, and I'll be conducting an analytic study of them uh, with different controllers in a wireless environment. And I will tabulate all the results I get, and I will, based on the findings I receive, I will um, declare the best SDN controller for a wireless environment. So the main focus of this project is we'll be studying the performance of different SDN controllers with a single and linear wireless topologies, and I'll be analyzing the following parameters: delay, throughput, and jitter. A little bit about the parameters. Delay is the time that is taken between the packet transmission and the packet reception. Uh, and throughput is the amount of data that is transmitted successfully between the sender and the receiver. And the variation that occurs in the delay while sending the packets is known as jitter. So here's a summary of the five similar works that I found, which is relevant to my project. So the first paper actually conducted an extensive study of performance of SDN controllers in the normal MiniNet environment. They constructed networks of different topologies and analyzed their performance in terms of the delay and throughput. The next paper is based on, it introduces the Mininet Wi-Fi software and provides a explanation about the different features. The third paper actually used the Mininet Wi-Fi. They constructed a simple linear topology and studied their performance in various detail like uh, jitter, delay, and throughput. The fourth paper that I use as my reference, they also studied the performance of a software-defined wireless network and considered the delay, packet, jitter, and packet loss criteria. So how is my work different from the others is that I'll be using a simple graphical tool called GNU plot, and I'll be using this to create the delay and throughput graphs. And GNU plot is a very simple tool to be used, especially in a Linux environment. And this is what actually made me choose the tool for this project. So how is this work useful? So this work through this work, I hope to introduce Mininet Wi-Fi to everyone in the STM class and beyond, and which I feel is a very useful resource in studying the performance of uh, SDNS wireless networks in greater depth. And by studying the performance of SDNS wireless networks with different controllers, we can have an understanding of how SDN controllers perform with both wired and wireless uh, network simulations. And this will hopefully be a step forward in the SDNization of wireless networks. So these are the simulation and details of my project. I'm using Mininet Wi-Fi version 2.5, and the OS is Ubuntu 18.04 LTS. My host RAM has 8 GB, and I have allotted 2 GB of it to my VM. And setup details is I'll be creating a single topology with one access point and three stations, and I'm creating a linear topology with three access point and three stations. So controllers I've used are RIU and POX, and the parameters I've monitored are delay, throughput, and jitter. And the tools I've used are GNplot. So a little bit about Mininet-WiFi. Mininet-WiFi is nothing but just a fork of the Mininet SDN network simulator, which is well known to everyone. And it just extends Mininet's functionalities by adding virtualized Wi-Fi stations and access points. It used for its running, it uses standard Linux wireless drivers that are already available in the Linux system, and it also includes the 802.11 HW wireless emulation driver. And Mininet Wi-Fi also supports normal Mininet operations, so that you can be able to create normal Mininet topologies as well. So stations are any devices that can connect to an access point after successful authentication and authorization. It's kind of analogous to hosts that we have in Mininet. Access points are devices that oversee all the stations and are responsible for accepting and rejecting a connection requests from stations, which are analogous to switches in Linux. So the tool which I use for plotting the graphs is GNUplot, which is a command line graphic utility tool, which can operate on various platforms like Linux, Windows, and so on. And it was created with an objective to enable scientists and students to represent their results that they get in a very simple manner. So these are the topologies that I use. This is a single topology structure with one access point and 3 stations and a remote controller. And the single topology, this is how I created the single topology. This is a command which I used. And I just tested the pingall with the pingall command to verify the working with RIU controller. And these are the graphs that I got with RIU. And similarly, I ran the topology with the POX controller, and these are the results that I got. And this is a linear topology. It has 3 access points and 3 stations and a remote controller. And this is the command that I use to create a linear topology. And this is the working of the linear topology. And these are the delay and throughput graphs that I got for this topology with the RIU controller. And these are the graphs that I got with the POX controller. So based on the graphs that I got, I can infer that the delay and throughput values are kind of similar for the RIU and POX controllers. But one thing we can note is that POX has less jitter when compared to RIU. And the change in topology, that is between single and linear topologies, it has a negligible impact on the values of the delay, throughput, and jitter. And from the above results, based on POX's lower jitter when compared to RIU, I would say that POX is a better controller than RIU. So in future, we can include more controllers into the study, such as Open Daylight and Fedlight, which I was not able to do due to time constraints. And since Mininet Wi-Fi is relatively new, but I feel it has great potential in the study of SDN, in the study of the role of SDN in wireless networks, and it has a very active uh, forum where you can get all your doubts cleared instantaneously. So I feel that Mininet Wi-Fi has a bright future ahead in the SDNization of wireless networks. So these are the references that I've used for this project. So thank you for your kind attention. Are there any questions?
Hi Vishwat, I'm Samriddhi. My question is, why did you only use single and linear, or what do we say, or topologies for the project?
So like Mininet Wi-Fi as of now, like it supports it supports only single and linear topologies, and for any everything else you can create other topologies by using a script. But since my focus was on studying the performance with different controllers rather than with different topologies, I chose to stick with the default topologies that were already available with the software.
Okay.
Any other questions?
Vishruth, hi
Yeah.
Vishruth, I'm Jayesh. Nice
Okay.
presentation.
Thank you.
I would like to know, like, is there any difference between Mininet-WiFi and Mininet since you used only 8 GB laptop? So is it something a light version of Mininet or like what?
So as I said, Mininet-WiFi is just an extension of Mininet. It adds the wireless uh, capabilities to Mininet. So it's just an extension. And as such, I don't think that there's a very significant difference as such. I mean, for me, it felt like just using the normal Mininet software. And regarding the 8 GB RAM of my host, it was not a limitation as such since I used only one VM. But yeah, the only drawback would be that my computer was a little slow. But other than that, I didn't face any issues.
Okay, thank you.
Uh, Thank you, everyone.